Hey everyone, and welcome. If you're an architect or a cloud engineer, you know we spend a lot of time building for success. Well, today we're flipping that on its head. We're going to talk about architecting for the absolute worst case scenario. We're putting together a practical guide to building seriously resilient, cross-region disaster recovery systems right here on Google Cloud. Let's dive in.
So let's just kick things off with the one scenario that probably keeps a lot of us up at night. Imagine it, a massive fiber cut, some crazy natural disaster, whatever it is, an entire Google Cloud region just goes dark. All your production services, gone. Your apps are down, your users are freaking out, and every second costs you. You know, this isn't just a tech problem, it's a full-blown business catastrophe. So what do we do about it? How do we even begin to prepare for that?
Okay, so the first thing you've got to understand is that disaster recovery, or DR as we'll call it, isn't just one single solution. It's really more of a spectrum. Think of it like a balancing act between how much you're willing to spend, how complex you want to get, and most importantly, how fast you need to get back online. Let's walk through the three big patterns. So on one end of the spectrum, we've got backup and restore. This is the classic, what we call the coldest approach. It's pretty straightforward. You take regular backups of all your data and your infrastructure code, and you just ship them off to another region for safekeeping. If your main region goes down, you literally spin up everything from scratch using those backups. Now, the huge upside here is cost. It is by far the cheapest way to do DR. The downside? You're looking at a recovery time of hours, maybe even days. Moving up the scale a bit, we get to the warm standby. And honestly, this is a super popular, really balanced option. The idea here is you have a small, kind of skeleton version of your production environment already up and running in a second region. And the absolutely critical part is that your data is actively being replicated in real time. So when disaster strikes, all you have to do is scale up your servers and point your users over. It costs a bit more, for sure, but your recovery time, we're talking minutes, not hours. And then we get to the far end of the spectrum, the hot standby. You'll often hear this called an active-active setup. This is the Rolls-Royce of resilience. You're basically running a full-scale, identical twin of your entire application in a second region. And here's the kicker. Both regions are serving live traffic all the time. If one region goes down, the other one just picks up the slack instantly. No one even notices. This gives you basically zero downtime. But as you can probably guess, it's the most expensive option since you're doubling your infrastructure. Okay, this table really lays it all out and brings those trade-offs into sharp focus. We're looking at two really important metrics here. First is RTO, your recovery time objective. Basically, how fast do you need to be back online? The other is RPO, your recovery point objective, which is all about how much data you can afford to lose. As you can see, backup and restore is low cost, but your RTO is huge, and you might lose a few hours of data. Hot standby, near zero for both RTO and RPO, but that cost is way up there. And warm standby sits right in that sweet spot in the middle, a fantastic compromise for a lot of use cases. All right, enough theory, right? Let's get our hands dirty and make this real. We're going to walk through a quick blueprint for building that popular middle ground solution, the warm standby, for a pretty typical SaaS application. So here's our starting point, our home base. In our primary region, let's call it a central one, we've got our whole application stack running. We have our load balancers, our auto-scaling groups of VMs for the app, and of course our main database. Everything is running perfectly, serving live users. Standard stuff. Now, let's hop over to our standby region, say US East 1. Over here, we've already set up the core infrastructure. The networking is all there. But instead of a whole fleet of VMs, maybe we just have one tiny instance running in our instance group. It's that skeleton crew, right? It's ready and waiting, but it's not running at full scale, which is key to keeping our costs down. And now for the most important piece of this entire puzzle, the data. We set up our Cloud SQL database in the primary region so it's constantly, automatically replicating every single change over to a read replica in our standby region. This is the lifeline. It ensures our data is always up to date and ready to go. Because let's be honest, without this data link, our standby environment is, well, it's pretty much useless. Okay, so we've built it. Our primary region is running, our warm standby is sitting there waiting in the wings. But how do we actually flip the switch when disaster strikes? This part, the failover mechanism, is just as important as the infrastructure itself. In Google Cloud, you've basically got two main ways to do this. The first is a classic DNS failover. You just go into Cloud DNS and update a record to point your domain from the dead region's IP to the new one in your standby region. It's simple, it works. But the catch is that DNS changes can take time to spread across the internet. The other, more sophisticated option is to use Google's Global Load Balancer. It's constantly running health checks, and the moment it sees the primary region is unhealthy, it automatically starts sending all the traffic to your standby region. It's way faster, almost instant, but yeah, it takes a little more work to set up. So, we've talked a lot about the how, but we can't ignore the business side of things. It always comes down to this core question, this fundamental trade-off between how much your DR solution costs and how much resilience your business actually needs. And this chart, it doesn't lie. It makes the financial reality of DR crystal clear. You can see that your ongoing cost is directly tied to how fast you want to recover. That cold, backup and restore strategy is the lowest bar on the left. A warm standby is a very manageable increase in the middle. But that full, active, hot standby on the right, you're effectively doubling your monthly cloud bill. Which brings us to what might be the single most important question you have to answer. Don't just look at the line item for the DR infrastructure. You have to weigh that against the true cost of an outage. How much actual revenue do you lose for every hour you're down? What's the long-term damage to your brand's reputation and your customers' trust? You know, for some companies, a single hour of downtime costs way more than an entire year of running a warm standby environment. So after all that, we land here. How do you actually decide? How do you go to your boss, to your CFO, and justify what can be a pretty significant investment? Let's try to nail down the final verdict.
So you should be nodding your head yes to cross-region DR if any of these are true for you. Is your application absolutely mission critical, meaning the business just plain cannot function without it? Do you have strict SLAs with your customers, or maybe regulatory rules that require this level of availability? And, like we just talked about, is the financial or reputational hit from downtime just unacceptably high? If you're checking those boxes, then this investment isn't just a nice-to-have. It's a business necessity.
And I want to leave you with one last thing, and it's probably the most important takeaway from all of this. You can go and design the most brilliant, most resilient, active architecture on the planet. But if you've never actually tested it, if you've never run a real failover drill and seen what happens, you don't really have a disaster recovery plan. You just have a disaster recovery theory. And trust me, you don't want to be testing your theory for the first time during a real disaster. Regular testing is the only thing that turns theory into true resilience.